Alright, this video we're talking about Unit 6, Booleans. The review asks you to think of the data types that we've seen so far, and that one actually is more the general stuff that we would write down in our contracts. So we've seen numbers, we've seen strings, we've seen images, and that's all I can think of at this point. Now, there are other data types, and today we're going to be learning about the biggest, or not the biggest, but a very important one called a Boolean. And, well, you'll see in just a second. The next slide wants you to consider what these expressions evaluate to, what type of data types they create. Now, I actually followed their instructions. I said if you're not sure, you type it in. So I typed it all in over here into my interactions area, except for the last one, because the last one's different and I don't have a specific answer for that one yet. I know that if adding, so I know that adding two numbers gets me a number. Adding or dividing two numbers gets me a number. The circle function, I put in different data types to get an image. And then number 4, I'm putting in two numbers, but I don't know what I'm getting out yet. And I want to make a quick note for you guys. These things here, why am I doing this with the mouse? I need to use my pen. The functions in the more blue-gray font at the very beginning of each parentheses, that is your operation or your function name. You need to know that that is not the same thing as your domain. That is not your input. That's you telling the computer this is what you will do given these things here. So if I go over to my interactions area and hit enter, it says the word true in a new color of font that we have not seen yet except for close to the error messages. And it's a word, but it does not have the quotations around it. That means that this is a new data type. Next, they want to focus in on that last expression. They said it compares the numbers. And it tells you, of course, that you got true, which we've already seen, but then it wants you to consider what happens if we swap those numbers. Will we still get true? So if our numbers are swapped, meaning I have the function less than 4 and 3, what will I get out? So I want you to take a very quick guess, take like 3 seconds. If you guessed false, you were correct, because this function says we're going to check that our first number is less than our second number. So I'm going to write a false in here real quick. I forgot to note what this question in the gray box asks you. Can you think of some other tests? So I want you to take a few seconds and make a couple notes of other tests that you think would follow these ideas of comparing numbers. All right, now I've got some answers I'm going to show right now. I realize I should be letting you guys know when I'm going to show answers instead of just clicking that out. Now, I've got the other functions that I think compare numbers in the same way. Less than, greater than, less than equal to, greater than equal to, and equal. And then I wrote out what the code would look like in my mind following these structures. But, and I actually went through this with my students in class yesterday. I don't know what kind of keyboards you guys have, but my keyboard does not have a less than equal to button. And so I wrote that as when I was talking to the students, I was like, well, let's see if we can't just try putting less than equal and see if that works. And so I actually went over to my interactions area just as the class was watching, less than equal, and I did 3, 4, and it works. It tested it out, and I know that 3 is less than or equal to 4. And let's test it in the opposite direction, meaning 4, 3, and see if that's still false. Yep, 4 is definitely not less than or equal to 3. So for that one, testing it out got me that I can actually use these functions. I just need to put those two operations next to each other. And then um, one student mentioned not equal to. And that is definitely something you want the computer to be able to tell, but I don't know how to do it at this point in time because I tried out slash equal, equal slash. I tried the backward slash equal, um, and then equal backward slash, and none of those worked. Those all came out with this variable is not defined. So I'm not exactly sure how you would get this one to work. Okay, I'm gonna close this up and show you guys the next. So this is some valuable information that's here. I like the two examples they gave. You read those through. Now I wrote out a few notes that are summarizing what they said and is just information for you to remember. A student was saying that vocabulary is a really hard thing in this program because there are so many different terms that you need to know and you have to refer back to. It might be helpful for you guys to kind of just keep a cheat sheet of all of the terms on the side. I wouldn't make that for you guys because I don't know what terms are important for you guys to remember, what terms are easy to remember. That's all up to you. Close this down. The next slide wants you to test out typing in a number and hitting enter, a string and hitting enter, false and hitting enter, and then I actually added true and hitting enter, and seeing what you get back every time. A number, when you hit enter, you're evaluating it in the computer. It evaluates to itself. A string evaluates to itself. False evaluates to itself. True, same thing. And so they're trying to show you that even though it's a new type of data that you haven't seen before, it still performs in the same way in that it's just another operation. Not operation, but it responds to operations in the same way. And then, oh, sorry. Ooh. um, then they gave you these four Boolean functions, and they wanted you to convert those into circles of evaluation. I'm going to give you a few seconds to pause and try that. Okay. Oh, I clicked it and didn't tell you. Um, I'm going to show you my answers now. So I took these four and I just broke them down based on their main operator, the Boolean equals, less than, I'm sorry, greater than, less than, and equals, and then wrote those in circles. 1 and 2 are pretty basic. 3 and 4 had operations embedded within the Booleans. And in fact, if you'll notice, number 3 has two separate operations and then a comparison. That's pretty useful to be able to compare and see if those two operations, which one is greater and which one is less, without actually doing the calculations. That's not something you can normally do. Normally you have to do that evaluation first. Then they wanted you to convert it into code. So I'm going to pause it. I'm going to type my code in to the interaction side, and then I will show you my answers. So I want you guys to give it a shot as well. All right, I've got my answers covered up so that way I'm not just revealing them all of a sudden. I'm going to show you my answers now. I've got them typed in these 4 lines here. So you should have gotten false, false, true, false. Now, a very common mistake that I saw my students making in class, and I was about to do it too for number 2, the negative 13 is greater than 5. I was trying to type in negative 13 greater than 5, and then students will get expected a function given this. And some will recognize, oh, I need to put my operation first, but it's just, if you get something that says expected a function and you put a number at the beginning, then your order is out of place. And so you need to use that error code to help you understand what's going on. Okay. Read through this slide really quickly, and I want you to note, well, I'll give you a second. Okay, I want you to note some important questions and some important pieces that we've gotten to so far. The first thing is they ask where else might a programmer might want to compare two strings. I really love this password example, and that is a very rudimentary way that you can test a password. You can type it into your definitions and then compare what you've been given with what was stored in the program. And that is how very unsecure programs do passwords. That's not something we can do anymore. We have to have a lot more backup to it just because hackers ruin things for everybody. But there are other reasons that you might need to use a Boolean to compare two strings. Um, so I actually have, let's see, not this one. Oh, let me pull up my game real quick. My game coding. Don't freak out by what my game looks like. I've got extra stuff in here that I've added in as I've been trying to teach this program. But if you'll notice, I have this new function that we'll talk about in just a second, comparing keystrokes up, down, left, right, the A button, the X, T, B, S, D, and H, just because I had all um, these different functions working in my game, and you need to be able to compare the strings to what you're typing in. Okay, so let me go back to this. It says make sure that you've written down the complete contract for all four Boolean functions. I don't know what four they're talking about. I guess they're skipping less than or uh, less than or equal to and greater than or equal to, and saying that you've only gotten less than, greater than, equal, and string, this new one. So this new one where you're comparing two strings is called string equals huh. And it compares two strings to see if they're the same. So it's again called string equals huh. I'm not sure why that's how we say it, but they said seriously that is the name for this function. So if I tried to type this one in, string equals huh, apples, oranges, it tells me it's false because those are not the same string. String equals huh, apples, apples. Of course that's true. Now I could come over here and make let's define a function real quick. Let's define the word oranges to be the string apples. Yeah, let's see if that works. I had to click run or else it doesn't work. String equals huh. So I want the string apples and I'm going to compare it to the function that I just defined called oranges. I got my computer to say that apples equals oranges. In a way. Hopefully that makes sense to you guys. But that is one way to show that string equals huh doesn't mean you're just checking right next to each other. You're checking other functions too. This next one, I'll give you guys a few seconds to read through the scenario listed here once you open up the cage program. This is my cage, and that's Sam the butterfly moving around. Okay, I'm going to go to the next slide. There's a little more scenario for you to read here. Okay, then they want you to go to page 19 in your workbook. I don't think I have my workbook open yet. There we go. Page 19. Okay, so they give you the design recipe problem setup first. I'll give you guys a second to read through all of this. So pause it and read. All right, now this is, it's valuable for you to kind of visualize what's happening, looking at the cage here and looking at the coordinates. So if you move all the way over to the left, I can still see him at -40. So -40 is allowed, but that's weird. It's not letting me. Oh, I'm opening up my cage where I've already. Oh, I'm sorry, guys. I opened up my cage where my answers were already at. I don't want you guys to try and cheat and use that. Um, Let me open up the program. Yeah, so this is where it's not blocked off yet. So at -40, he can be seen. But past -40, we cannot see Sam anymore. And that means that -50 is too far. But everything inside of -50, well, not everything, but greater than -50 is okay. And then at 680, I can still see Sam. At 690, I can't. So everything less than 690 is okay. So we have this window where, sorry, let me open my workbook back up again. We have this window where it's everything in between these two numbers is fine. And so this one here is saying x needs to be greater than -50, greater than this window here, and that x needs to be less than 690. That's what I put in for my piece of Sam still visible. So I want you to now take that and make a quick circle of evaluation for each one. Okay, I'm going to show you my answers. These are my circles. And basically these have to be true for Sam to be following his mom's rules. We have to design it in a way that if it's true, Sam is good. If it's not true, Sam is not allowed. Okay, next slide. I want you to read through this and take a look at the code that is there for Sam so far. Remember the term dummy definition, meaning that it's in place for you to fill in the code. That is definitely happening here. Give you a few seconds to pause and read through. Read through this slide real quick, and then we're going to take a brief mention of it before we go to our workbook. Okay, now it says safe left is ignoring his x coordinate and returning true no matter where he is. Well, if you look at safe left's definition, right now, all it says is safe left is x. Well, we're not saying what x has to be. X can be anything right now, so any number would be true. So it's not that it's ignoring his x coordinate, it's just that there are no restrictions on his x coordinate. So we have to put those restrictions in, which is why we go to the workbook. And I'm going to do this design recipe with you guys rather than pausing it so that you guys can see my thought process. I have a lot of students in class who are just jumping straight to the coding and they are not working with the contract, they are not working with the purpose statement, they're not making examples, they're just going straight to a definition. That is not good programming. You guys need to make sure that you are always thinking through every piece first. So the function name here, we've already said we want to call this safe left. And it's got a question mark or a because we're seeing, is it true? Is he safe on his left? And what we're doing is we're giving it, so it says it takes in an x coordinate. So an x coordinate is a number, and it checks to see if it's greater than -50. Well, if it's checking, that means it's comparing greater than. That's a Boolean. So what does the function do? It takes the x coordinate, I'll put x coord, and compares if greater than -50. All I've done is basically rewrite what my directions are into my contract state. My contract right here, this is my contract, and my purpose statement. I have now taken everything I need from the problem, and I should be able to refer back to this for everything that I could need. Now my function name, I've already said is safe left. By the way, guys, when I'm doing the audio narrations of the videos that didn't have any audio, I realized how messy my handwriting is. I'm sorry. It's the best I can do since writing on a computer. And it takes in, my input is a number, and the number is an x coordinate. So let me make up an x coordinate. Let me go with -240. And let me go with, oh, let me continue. What it produces. So it's comparing if the number is greater than negative 50. That's what the computer should do when I plug in safe left negative 240. Just say, well, is it greater than negative 50? Let's do that again. Let's go with 302. So it should say, is this greater, I'm sorry, is 302 greater than negative 50? And then before I go on to my definition, the next thing I have to do is I need to say, well, you know what? So this is actually how I work through it. I say, well, safe left stayed the same every time. Oh, needs a question mark. Safe dash left question mark. My numbers changed. Let's see. And then my function had a parentheses both times, had a greater than both times. Those numbers changed, leave a space, and then it had a negative 50 both times, and then a closed parentheses. So I saw when I was writing in down here, these guys changed and these guys changed, and both of those represent my x coordinate. So I'm going to call my variable x coord. A lot of people are not defining what their variable is by finding the differences. You have to do that if you want to say that you've got good practices going on. All right, so they said once you've typed in the example, click run and see if Sam is prevented from flying off. So what should happen is the computer says, okay, whatever his x coordinate needs to be greater than negative 50. If not, he can't go there because it's false. So I'm going to now pause the video. I want you to take this and use it in your coding for Sam the butterfly and see if you can't make safe left work. I'll tell you in a second. All right, I got my answer hidden, but I want you to see it and wanted to warn you. So I changed this second line the line 4 information to match my purpose statement. So I have my contract, I have my purpose statement, I have example 1, example 2, and my definition. Now I don't know why they have this parentheses true here. I'm just going to take that out. I don't think that should be there. I should have hit enter to show that this is a definition and enter to show that this is still part of my definition, but you don't have to do that. That's just me showing. See, I guess I could have done that for my examples too. Again, you don't have to. When I was in the training, the program creator told me, you need to stop writing everything in a straight line, in one line. So I'm trying to be vigilant for you guys. So if I click run, all right, nothing new shows up whenever I first click run, but I want to test, have I created a safe left for Sam? I don't know if you can hear me banging on the left-hand key. Nothing's happening. I can't get him any further. He now has a boundary on the left side. So it worked. So I want you to take a look at that. And the next slide tells you to do the same thing. And in the page, use the workbook, the design recipe to create your safe right coding. I want you guys to do that, and the next time I unpause, I will have my safe right code just typed in. I'm not going to do the contract, so that way you guys can have a little bit of effort on your own part. Okay, now this page here asked us to do safe right, and I told you guys to try that, and I was just going to have it typed in. But then I started kind of worrying because when I did my safe right coding and then clicked run, nothing was happening. It wasn't stopping it. I tried several different combinations. I pulled up the teacher workbook and looked at my coding to see if it matched what they had, and it does. And so I didn't understand what the problem was. I thought, well, let me see what else they're telling me. And in the next slide, you can read this for yourself, but basically they're saying, is it working the way you expected? Look at the example or the next definition for on screen, huh? And it says it's only talking to safe left, huh? So if you look at the on-screen function, and it says it's protected on the left and the right, but if you look at the definition for on-screen and safe left, it only has safe left. So on-screen must be something that works under the hood again. Not just under the hood, but somebody they designed it, and you are just doing the basic replacement and parts fixing, but you can't design the program, and so you're missing something. On screen needs safe right to work, and if on screen doesn't work, then safe right doesn't work apparently. So I have my safe right function here, but on screen needs to be doing something as well. It needs to have safe left and safe right. So the first thing I'm going to do, not even reading what they have, I'm just going to try putting in, oh, I did safe left again. I'm going to try putting in what they have here. Have it work for safe left and safe right. And let's see if that works. Expected only one, but found one extra part. So that's not enough. So let me move on to the next screen. And look, they're talking about and, or. We've talked about these comparisons for Booleans that were comparing two numbers. That's it. But we know that there are more than one types of, there's more than one way to compare things. So they want to combine the safe left comparison and the safe right comparison. Sometimes you might do or, but in this case that's not what we're talking about. So notice this is a very important little note for you. I would write that down if I were you. They want you to return, or they want and to make sure that both characteristics are true. But or works if either one is true. So if I would make a very big note if you're having trouble with this idea. I'm going to pause it because they want you to look at page 22, which is writing two circles of evaluation. Well, I'm going to pause it and then I'll let you guys know whenever I'm, well, you know what, I'll just, I'm going to give you a few seconds to pause it, try it, and then I'll let you know whenever I'm going to show you the teacher workbook answer. Okay, I'm going to reveal the answers now. This is what your circles should look like. And the coding. It says and convert them to racket code. So, and if you're comparing both, if you're testing that both 2 is less than 5 and 0 is equal to 6, you would type that in as this, and both of these functions. If you're comparing or, it's the same idea, well, the different number here, but the same idea is just instead of saying and, it would say or. And I want you guys to pause and take a guess as to what this will look like in the racket code. I'm sorry, what I meant is what it'll look like in terms of the answers, true or false. Okay, so I've got the very first one typed in, and I want you to consider and means that both parts are true. The first part and the second part are true. And if they're not both true, then the whole statement is false. And so in this case, 2 is less than 5, but 0 is not equal to 6. So your second part is not true. So if you guess that this would return with a false for the total statement of both of them working, that's correct. And then the second one, I couldn't type it in without showing that answer. So the second one, we know that 2 is less than 4 and that 4 is not equal to 0. But we only need one of those to work for this whole statement of or to be true. And since the first one is true, then the whole statement is true. All right, the next slide, oh, no, I'm showing you the answers. The next slide wants you to complete the on-screen function by putting both safe left and safe right. So both. So the on-screen function needs both safe left and safe right, and you're just testing for both, which means that you want the and function. So hopefully you guys can pause and try doing page 23's word problem on screen, and in a few seconds I'll show you the answers. This is the coding that they had for their examples. Notice that they're using the variable x. When I type mine in, I put x coordinate. I don't like just having the one letter for the variable. Not in the computer programming. It's a little weird to me. So I went into my coding. I typed in the two examples already. So I did example on screen and safe left, safe right. Example on screen and safe left, safe right. So my definition, I have on screen and so I hit enter so that I can show what are the two characteristics of and that I need. And notice there's a tiny indent there to show you what two, that you have the two characteristics. So I'm going to put x coordinate, safe right, x coordinate. And then now I just want to close up my parentheses. That's closing up the and I want to close up the definition, and I should be good. Let's see if I click run. Hopefully he'll be locked in on this side. Yes. He cannot go further than 680. So the reason that he wasn't working before is because safe right wasn't part of the program. You know what? I clicked that before clicking pause. Give me just a second. All right, the slide that I just randomly clicked to before reading, you actually have a lot of information that they want you to go through in these next few slides, and they're starting off here. They're saying you could do on screen by talking just about the coordinate x, but you could also talk about it with the functions that we've already written. We've written safe right and safe left. Those took a lot of work too. And they have a very important question here about whether or not it matters. I am not the best to explain why it does. They have 1, 2, 3, 4, 4 slides that are important for you to read through and understand what they're saying. These guys are just true computer programmers that spend their lives working on that and education. So take their words as good advice here, and if you do have a problem with that, if it doesn't make sense, then definitely talk to me about it, but hopefully you can see why it's good to have several simple functions rather than a single complex one. All right, the last thing I'm going to do for you in this unit is they wanted you to open your game file. So I'm going to save this code for a minute. Close these. I'm going to go back to, I'm going to go to my game. No, you know what? I'll go to, I don't have it. Game template. So you have a game saved already because you've already added in background, danger, target, and players. But mine is a different code than yours. But so it says, and scroll down past the update functions. Where's update? Oh, update player. Here we go. No. For safe left, safe right, and on screen. Here it is. Yeah, so their directions here are not as clear to me. I clicked blank game, and so what I'm seeing is safe left, safe right, and on screen. It says, right now they're all true. Since your game screen has the same dimensions, you can use the same code as Sam's yard for each of these 3 functions. So I can go to this coding that I made for all of this, and I can actually copy it, and I'll go here to safe left, and I'm going to paste it. Let's see, when I click run, start variables not defined. Oh no, what did I do wrong? Let's see. It says define on screen, so let me take this stuff out then and paste in here, and I'll take this start on screen off and take this define on screen off. Now let me see. Expected to open at line 99 to open this. Oh, so I don't know what this true part is. I'm just gonna take that off real quick. Yeah, there we go. So my player's not moving yet. I don't have any movement, but I do believe that as long as you have this coding that you used for Sam's Yard, it should work in your game. So you could save it under the remix floppy disk button. And once you click remix, it'll say save from that point forward. This is where you would change the name. Save. And if you don't, I don't recommend this, but I'm going to leave these. Refresh mine. Yeah, so this one where I just randomly click some buttons, I'm going to delete that. You can delete if you needed to. Alright, that is the end of Unit 6. They've got a closing here for you. These Booleans are what we're going to do to move pieces of our game next. So look forward to that. And this video was a little shorter, so we're working our way through it.